Most of us are aware of the fact that we are using too much plastic. Way too much plastic, actually. To put the global plastic production into perspective, let's imagine the largest animal on Earth, a blue whale. Or better, 10,000 blue whales, the current estimated population roaming our oceans. The weight of plastic produced currently in a single year equals a staggering 4.5 million blue whales. That is 450,000 metric tons of plastic produced in a single year. And it's going to get worse. Plastic production has been steadily increasing every decade over the last 50 years. Unless we take action, it has been estimated that by the year 2050, which is not that far away, by the way, we will be producing a mind-blowing 1 billion tons of plastic per year. Now, I have not converted that number into blue whales, but it's too many, way too many blue whales. At the center of the problem is what we do with all this plastic. Currently, the main use is packaging, with nearly 50% of the global production spent on making it. Packaging has a very short life. It typically takes 6 months or less for plastic packaging to reach the end of its life and to be disposed of as plastic waste. Sadly, in many countries, including Australia, the great majority of that waste goes directly into landfills. A small portion escapes, or even worse, is discarded directly into the environment. It's no surprise then that we find plastic waste everywhere on our planet, from the highest mountain tops, including glaciers, to the bottom of the deep sea. For example, plastic debris makes up 80% of all marine pollution. What happens in nature is that forces such as the sun and wind break down plastic into small particles. These so-called microplastics are only a few millimeters in size, but they persist in the environment for a long time. It can take anywhere from decades to thousands of years for it to fully decompose. And microplastics are ingested by animals. They have been found in fish and other seafood, but also in milk and even in meat products. Recently, microplastics were detected in us humans. First in human lungs, then in human breast milk, and even in human blood. That, of course, raises health concerns for all animals, including us humans. To come back to our blue whales, when they feed on plankton in the oceans, as they usually do, minding their own business, they are actually ingesting a staggering 10 million pieces of microplastics per day. That is 44 kilograms of plastic each day. Of course, that is not a healthy diet for a blue whale and will likely reduce the number of those majestic animals even further. So what can we do to solve this plastic waste crisis? To save our blue whales, us humans, well, the entire planet as a whole? The slogan, reduce, reuse, recycle, sums it up nicely. First, we have to reduce the amount of plastic that we're using in our daily lives, especially plastic packaging. Second, we need to shift to reusable products. That works very well, for example, with reusable cups. If I get my morning tea here on campus, it's great to see that most people now bring the reusable cup to the coffee shop. If you do this, just remember, reuse the cup for as long as possible. Ideally, at least 100 uses to optimize the environmental benefit over a single-use cup. And the third step we have to take to get us out of this plastic waste crisis is that we need to recycle all, yes, all the plastic once it reaches the end of its lifetime. Currently, recycling rates are depressingly low. In Australia, we recycle less than 13% of our plastic waste. The great majority, more than 80%, goes into landfills. That means, for example, if you go to the grocery store and buy food in a plastic tray, on average, only 1 out of 10 plastic trays is recycled. The other 9 are buried in a hole somewhere, probably close to where we live. Comparing internationally, even the European Union, which has one of the most advanced waste programs, recycles on average only 40% of plastic packaging. The United States, that's a particularly sad example with a national recycling rate below 10%. But why? Why are we such poor recyclers? There are many contributing factors, such as a missing, or especially in Australia, a fragmented legislation where each state, territory, sometimes even county has its own rules. And that usually goes hand in hand with a lack of consumer education. But the big one, the main reason why we are such poor recyclers is money. Currently, producing new plastics, also known as virgin plastics, from fossil fuels such as oil and gas, provides cheaper and higher quality products compared to recycled plastics. This is mainly due to the recycling methods that are currently available. Large-scale commercial recycling in Australia and most other countries around the world is based on mechanical recycling. This procedure involves collecting plastic waste, washing it, grinding it into small pieces, and then remelting it into recycled products. However, this method has been dubbed downcycling because it usually impacts the quality of the material. So mechanical recycling usually creates lower quality and therefore lower value products that are in most cases less or even non-recyclable. For example, take a food-grade beverage bottle. They can be recycled, or better, downcycled into a park bench, which initially is great, right? Recycling, check, but at some point, this park bench will reach the end of its lifetime. And then it usually ends up in a landfill or is incinerated because the quality of the plastic is too low for further recycling. But what if? What if we would have a recycling method that is sustainable and does not impact the quality of the material? Well, such an approach is in the works. Welcome to biorecycling. Biorecycling is based on the use and the modification of naturally occurring enzymes. Enzymes are proteins that act like fire starters. They can initiate chemical reactions and make them run many, many times faster than they would ordinarily. In plastic biorecycling, we are after enzymes that can break down the long plastic molecules, known as polymers. We use those enzymes to cut these polymers into small monomers. And those are the building blocks to create high-quality recycled plastics. But where do we find such enzymes? In unexpected places, I would say. My research team found evidence for plastic-degrading enzymes in superworms that were munching on plastic pieces. Now, superworms are not worms, as their common name suggests. No, they actually have 6 little legs. So they are insects, yes. And those critters, they are the larvae of the darkling beetle Zoophobos morio. We found that superworms are able to eat the plastic polystyrene. That is the number 6 on your recycling charts and is currently mostly used for insulation, parts in refrigerators, cars, and airplanes. My research team conducted a series of experiments with superworms and found that they cannot only survive on a sole polystyrene diet, no, they even gained a little bit of weight by eating only plastic. And that suggests that superworms can use plastics for energy and growth. But how do superworms manage to digest plastic? We investigated the gut of superworms, and we found many bacteria, which by itself is not surprising. But several of those microbes showed the potential to produce plastic-degrading enzymes. So our conclusion is what happens here. First, the superworms ingest the plastic, and by doing so, cut them into small pieces. And then in the superworm gut, the microbes break down the plastic further using the enzymes they produce. The bacteria can live off those breakdown products and provide nutrients to the host. Currently, we are focusing on not so much on the superworms, but more on the bacteria from the superworm gut. We grow them in our lab to find out what enzymes they can produce and to learn how those enzymes function. The next step is then to use artificial intelligence to modify those enzymes, tweak them a little bit here, a little bit there, to make them more efficient so they can break down plastic even faster. Our long-term goal is to implement a plastic biorecycling process. Now, this process does not involve superworms, but it's loosely based on what happens inside a superworm. First, the plastic is mechanically shredded into small particles. And those particles are then transferred into a bioreactor. That's where we add the enzymes so we can break down those long polymers into monomers. And then we can recover those building blocks to produce high-quality recycled plastics. And to come back to our cost question, the money. The good news is that biorecycling is economical feasible. Producing enzymes, even in large quantities, is relatively inexpensive, and the biorecycling process as a whole does not require high amounts of energy, like other alternatives such as chemical recycling. Therefore, we strongly believe that biorecycling has the potential to revolutionize the recycling industry by producing recycled plastics that are equal in terms of quality and in terms of costs with new plastics created from fossil fuels such as oil and gas. But, and yes, there is a but, much research is necessary to discover all these enzymes, to find out how they function, and then to modify them to work faster. Eventually, we have to upscale this process to deal with the large amount of plastic waste that we're currently creating. However, my research team is optimistic that in the near future, we can ditch our nasty habit of digging out oil and gas from the ground to produce lots of plastic that then, after a short life, become waste and end up in a landfill. Instead, we envision that we will be producing less plastic, and all the plastic that is in use will be recovered at the end of its lifetime and seen not as a waste, no, but seen as the resource that it actually is, to be transferred through biorecycling into high-quality recycled products. Initially, those products will be made out of the common plastics we currently know, and subsequently we will shift to bioplastics. This entire approach will be beneficial for the climate the environment, animal life, and finally, us humans. There were once 250,000 blue whales on our planet. Let's work together to bring those numbers back and stop replacing blue whales with plastic waste. Thank you.